and a very warm welcome to all the resource person and participants in the day 3 session 1 of our 6 days Auto faculty development program on energy and sustainability, sustainable development through advanced renewable energy technologies. I hope everyone has been enjoying the past 2 days of insightful session and enriching interactions. Today is the midpoint of our FDP, and we are delighted to continue this academic journey with another exciting and thoughtful, provoking session. We are privileged to have with us Dr. Kumari Namrata, Associate Professor of Electrical Engineering Department of NIT Jamshedpur. Now, ma'am, with your due permission, I would like to read out your biography to our participants.
Yeah, please, sir. Go ahead. No issue.
Thank you, ma'am. Dr. Kumari Namrata, Senior Member IEEE, is an Associate Professor in the Department of Electrical Engineering at the National Institute of Technology, Jamshedpur, India, where she has served for over 2.5 decades. She holds a PhD in Electrical Engineering from National Institute of Technology, Jamshedpur. Her academic background also includes an MTech in Power System and a BTech in Electrical and Electronics Engineering. Dr. Namrata is a member of Board of Directors, IEEE Vice, and a lifetime member of the Indian Society of Technical Education. Her contribution to education and research have been recognized with the awards such as the Observer Young Excellence Award in 2023. She has received ISTE Best Teacher Award in 2024. She also received Best Poster Award at ICRERA 2014 in the USA. Dr. Namrata is a prolific researcher with a rich publication renowned with more than 100 research papers comprising high-impact journal articles, book chapters, and conference papers. She has authored 2 books named Wind and Solar Energy System and served as the editor of Springer in distinguished work Smart Energy and Advancement in Power Technologies. Notably, she has secured multiple patents in industrial predictive maintenance and AI-powered renewable applications. She is an active reviewer for prestigious journals including IEEE SS, IEEE System Journal, and Elsevier Solar Energy. Her scholarly pursuits are centered around vital areas such as solar power generation and conversion, microgrid modeling and control, renewable energy system, and techno-economic analysis of sustainable technologies. She has led and contributed to numerous funded projects in areas such as biogas plant, grid integration, electric vehicle charging, infrastructure, and IoT-based energy management system. As a committed academic leader and mentor, she has served numerous PhD, MTech, and BTech thesis on topic including solar forecasting, microgrid or optimization, hybrid renewable system, and smart grid technologies. She has organized and delivered invited talks, workshops, and conferences at national and international level, forecasting collaboration and innovations in renewable energy research. She actively promotes women in STEM and work for the advancement in the frontiers of clean energy system, smart grid, and sustainable technology development in India and beyond. This is about our eminent speaker, Dr. Kumari Namrata. Madam,
Yes,
uh,
sir.
the session is yours. You can now start with,
Yeah.
and we welcome
Thank you.
you.
Thank you so much, sir, for such a nice introduction. So thank
Yes,
you.
of course. Okay.
So before starting this session, I just want to convey my best wishes and regards by saying good evening to all. Honorable Director, I don't know where there is a director or principal. If I commit something wrong, please forgive me. Respected coordinators, faculty participants, and distinguished guests. So it is privilege to be here as a part of this Atal Faculty Development Program, organized by, just I am going through the brochure, organized by Swami Vivekananda School of Diploma, on a very sensitive topic and at the demand one, energy and sustainability, sustainable development through advanced renewable energy technology, by this AICT training and learning at Atal Academy. And even I would like to thank the coordinators, Mrs. Priyanka Datta, then co-coordinator, Mr. Sudeep Kumar Bed, and all the organizing committee members, whosoever are directly and indirectly related to this Atal FDP. So, coming to my topic, so first of all, I would like to know about the audience. All of them are the students or faculties are also there, I'm sure, because this is the program related to faculty development program. So, I'm pretty sure faculties members are also there, right?
Yes, ma'am.
Yeah.
Faculty visit
See,
members.
actually, according to my topic, I'm not going to give a very high-fi sort of presentation over here. But yes, I will start from the grassroots regarding the estimation of solar radiation and its impact on transition to green energy. I will just try to start it from the scratch. So before starting this session, just I want to brief a little bit about my institute. So all of you might be aware that it is a very old institute established in August 1960 as a joint venture of Government of India and the Government of Bihar in the chain of RECs, Regional Engineering College in India. So previously it was known as RIT Jamshedpur, but in 27 December 2002, when it was formally upgraded to National Institute of Technology with the deemed university status, RIT. So, yes, I don't think this slide is going to be justify the topic, but yes, I just want to brief something about the faculties over there. So there is a need of time. All of you have heard about IEEE. Hello. Hello.
Yes, ma'am.
Yes. Do you have any student chapter branch over there? Yes or no?
In our organization,
Yeah.
Swami School
Yeah.
of
Yeah,
Business.
sir. In your institute, do you have any IEEE student branch chapter?
Yes,
Uh,
ma'am. IST student chapter we have in our institute. We have IST student chapter.
yeah. Very good. Very good. So, are you people organizing some sort of program under IST banner?
Yes, ma'am. We do
Good.
organize
Very good.
eight events in a year
Okay.
under IST.
Very good. Very, very nice initiative. And apart from that, I will humbly request you try to have a IEEE student branch chapter. Right? It is going to give a big platform to the beginner like us for the exposure purpose. So here I am showing about my IEEE System Council of NIT Jamshedpur. So it has been constituted like this. So like this, you can also constitute a IEEE System Council branch over there. And regarding that, if you need any help from my side, please connect to me and we will try to resolve it. Right? So next one.
Okay, ma'am.
So this slide is showing about our IEEE System Council at NIT Jamshedpur. As you told, you have the IST branch like that. Apart from IST, we have this wing of IEEE System Student branch, and under that branch, we are trying to organize certain events yearly. Not certain 8-9 programs yearly we are organizing to make it feasible for the student to be getting benefited out of this, right? So in this IEEE branch only there is one wing that is known as WISE, Women in System Engineering. You might have seen in my slides, the logo is over there and all these things, right? So this is basically for the female participant. If someone is there, just try to go through the slides. So through this scheme, a lot of funds and a lot of scholarships are there, through which the women faculties as well as the women students can be benefited, right? So these are the program initiated by me regarding this IEEE student branch chapter in NIT Jamshedpur. In some of the institute also I am trying to have collaboration with, and with the collaboration of all this institute, I am trying to explore this IEEE student branch chapter at NIT Jamshedpur, right? So now coming to the point regarding my topic. So we can say that in this grappling world of increasing load demand and climate change effect, transition to sustainable energy is merely not an option. It is a necessity of the time. So but the question arises, why to go for sustainable energy, right? So can any one of you let me know? So it should be a mingling session. I don't want ki only I should speak, and whether you are listening or not, I don't know. So why there is a transition of energy scenario is needed in India right now? Can you let me know? So okay, then I have to go one way. So this is the presentation outline which I have to deliver today. So it is going to start with introduction, then energy scenario in India, then followed by energy consumption in India, then overview of solar radiation and its significance in renewable energy transition, solar radiation basics, factors influencing solar radiation, methods of estimation, importance of accurate estimation, solar data visualization, followed by solar energy resource assessment with one case study, and at last some references are there. So starting with this, as I told you, why it is necessary to go through the transition of renewable energy. So regarding that point, I want to say that why we should embrace renewable energy. You can see in this slide, right? Why renewable energy transition is needed. So the answer of this question is that as I have narrated, in a grappling world of climate change effect, increasing energy demand, the transition to renewable energy will not be merely the option. Uh, it's the necessity of the time. Now the question is that why we should embrace renewable energy and the positive impacts it will have on planet. So regarding that, the utmost point is that it's environmental imperative nature. So the most compelling factors towards the transition to renewable energy, as we are aware, most of the fossil fuels, when burns, comes out of with greenhouse gases as an output and make the air pollutant, but the renewable energy comes out with almost no emission. So here we can't say that renewable energy sources are not coming with, it is coming with no emission, but yes, it is going to lessen the amount of CO2, right? So a reduced amount of greenhouse gas is a vital point for mitigating climate change effect and reduces the air pollution. The second utmost point is easily available, as its name is renewable energy, means it can be renewed, right? You can use it again and again, so that it is known as renewable energy sources. So renewable energy sources like solar, wind, hydropower, etc. are abundantly available on this planet. As its names reveals, renewable means they can be renewed. It is not going to diminish, right? Like the fossil fuels, which is almost of depletion. The third most important point is health mitigating risk, right? Due to climate change effect and air pollution, the health problem like respiratory and cardiovascular diseases are increasing rapidly. And yes, really it is a very alarming situation for all of us. So transition to renewable energy can mitigate the effect of climate change and may provide sustainable environment for all the human beings. The next one is energy security. As we are aware, fossil fuels have to be purchased, and it create a dependency. It create a dependency and extra cost affairs. So transition to renewable energy will entail the energy security and geopolitical affair. That is a very vital point for us. Next one is with the help of renewable energy transition, we can create job. So we can say that job creation. How we can create the job? I will give one example. Suppose that by installing the solar rooftop panel, a simple person can sell the power electricity to other consumer and may open the door for job creation. So how that person can sell the power? Suppose that you have a solar panel on your rooftop and you have to run all your home appliances, and the approximate generation you need 3 kilowatt, like that, for a small house. And with the help of the solar panel, you are going to have 5 kilowatt generation. So 2 kilowatt is surplus with you. So you can sell that 2 kilowatt of power and generate the revenue. And the next point is, next one is just I am going through that. So by concluding all these things, we can say that transition to renewable energy is not a trend. It's a global movement for mitigating climate change effect, fostering innovation, creating jobs, mitigating health risk, and providing a sustainable life. And embracing renewable energy is not a responsibility. It is a commitment towards the coming generation for providing them a happy, prosperous, and sustainable life. In this context, in the session 2021-22, a conference at Glasgow has came up with a new scheme, was proposed, named as Panchamrit, in which 5 very important trucks were kept. All the 5 points right now I'm not remembering, but yes, it was there for the point like how to accelerate, how to expedite the renewable energy transition in India. So as in Hindu Sanskriti, we know about Panchamrit, means it has the capability to to give the life to the dead person. So this Panchamrit scheme was just like that, to make the system alive, to generate and go through the renewable energy transition like anything. So this was the answer of this question, why renewable energy transition is really needed. So we can summarize it all together. First one was environmental imperative. Second one was the mitigating health risk. Third one, generating jobs. Then reducing geopolitical effect. Means it is full of advantage with respect to the disadvantage. So why not to opt the transition regarding the renewable energy system. So next slide tells about, so you can see in this slide, in one line I can say that this graph tells a very important story. Even though the world is talking about green energy, the actual consumption data show that fossil fuels are still the backbone. You can see in this graph, means fossil fuels are still the backbone of global energy system. Solar radiation offers the largest untapped resources, yet the line representing solar and wind is still tiny compared to oil, gas, and electricity. So this gap shows uh, why it is necessary to go through the solar radiation, and improving solar technology is critical for an effective green transition. Coming to the next slide. This slide is showing simply the energy scenario in India. So you can see that in the last para, I have written the per capita electricity consumption, which was a mere 16.3 units in 1947, has increased to 1208 units in 2019 and 20. This data is a little bit old, but yes, it is to the mark, much lower than developed countries. Expected a sustainably increase, focusing economic development and ongoing industrialization. So again, coming to this graph is showing the figure 2. You can say this is showing the energy consumption in India. So following this trend, we can say that global energy consumption has grown across all sectors in the last 3 decades, and only solar energy has the scale to meet this rising demand sustainably. Same condition it is showing in figure 2. You can see that it is showing the total energy supply, that we can say that fossil fuel shares are shrinking and renewable shares are rising, and solar PV is becoming the world's fastest growing power source, driven by the limitless availability of solar radiation. Same scenario has been shown in this graph. This graph is showing the share of source power generation from hydro, wind, solar, and the source is the IEA data. This pictorial is showing about the renewable energy sources. You can visualize regarding the solar. It is installed capacity is 36.9 gigawatt. Wind having installed capacity 37.7 gigawatt. Targeted is 60 gigawatt. Biomass installed capacity is 10145.917 megawatt, and estimation of 500 million metric tons per year. So this graph is showing the environmental and economical aspects, right? Coming to the new and emerging energy storage technology program. So you can see that in the COP26 conference, India in Glasgow in 2021, as I have talked about the Panchamrit 5 points, you can just go through this one. So they have narrated that 500 gigawatt of non-fossil energy capacity by 2030. It is the target of that program. 50% of India's energy requirements come from renewable energy by 2030. Reduce total projected carbon emission by 1 million tons by 2030. Reduce the carbon intensity of its economy by 45% by 2030 compared to 2005 levels. Achieve net zero by 2070. Right? And the second one is EV30 at the rate of 2030 target, which aims to have 30% of newly registered private cars being electric vehicles by the year 2030. So the aforementioned plans necessitate India to develop indigenous, innovative, technically advanced, and economically viable battery components and chemistries. So I'm not going to focus regarding EV, because my topic is related to the estimation of solar radiation and its impact on the. So these are the certain literature review which I went through. Now coming to the point, all of you are listening or only I am speaking? That's why most of the time I am not interested in online classes. You know, it's a one-way door. Only you have to speak. Whether the audience are listening or not, it hardly matters. सुनाई नहीं देता, पता ही नहीं चलता.
No, ma'am,
So
we are
as I have mentioned कि हम कोई बहुत बड़ा चीज आपको नहीं बताने जा रहे हैं, हम बहुत स्मॉल से टॉपिक से स्टार्ट करेंगे. सारा चीज आपको ब्रीफ कर दिया मैंने, क्यों ट्रांजिशन की तरफ हमको जाना है, कैसे जाना है, और फिर वहीं पे आके हम फंस गए कि why solar radiation is needed. If we are talking about renewable energy sources, the prime one is the solar, right? Solar means radiation. Radiation means the amount of sunlights which we are getting on the earth surface, right? So the question is why solar radiation is needed. So it's a very crucial question. Try to understand. Suppose that if we are talking about any PV based system, without knowing the accurate solar radiation data, it's very, very tough to design the accurate sizing of your system. So as it has been written, accurate estimation of solar radiation is essential for optimal planning, sizing, and integration of solar energy system. So the entire system based upon based upon PV system is almost, I'm talking about the word almost, dependent on the solar radiation data. आपको जानना ही होगा. सपोज दैट आप जिस प्लेस में रह रहे हैं, कोलकाता में हैं, मैं जमशेदपुर में हूँ. जमशेदपुर में कोई एक हमको रिलायबल सोलर बेस्ड सिस्टम बनाना है, कैसे बनाएंगे? सिस्टम बनाना, मॉडलिंग एंड सिमुलेशन ऑफ रिन्यूएबल एनर्जी बेस्ड सिस्टम. कितना कंजम्पशन होगा, कितना पैनल लगेगा, कितना नेसेसिटी है, all the calculation we have to go for, in which the utmost important input parameter is the solar radiation. कितना solar radiation मिल रहा है आपको, कलकत्ता में पर डे कितना मिल रहा है, जमशेदपुर में कितना मिल रहा है. So we have to know about the solar radiation data, right? So again, the question is, what are the proper ways to achieve the solar radiation data? कैसे हमको मिलेगा solar radiation data, right? This I am talking from the perspective of the students, whosoever is there. This point I'm not talking for the faculties, because small project we have to make and assign to the student to achieve certain good projects, right? So there are only two ways to achieve the solar radiation data. The first one is by measurement, and the second one is empirical model, right? मेजरमेंट में क्या होता है? जैसे मैंने बोला, सपोज दैट यू आर सिटिंग एट कैलकाटा एंड यू हैव टू नो अबाउट द accurate solar radiation data for today. So what you will do? You have only two options. Either you can measure it. For measuring the solar radiation data, some equipments are there through which you can measure it, and these equipments are known as pyranometer and paralleliometer. Okay, measuring data for 2-3 days are okay, but can you measure the data, long-term data, for 1 year or 2 years? No, it is very tiresome. Who is going to measure the data for 1 year? Let me know. So to avoid this chaos of measuring the data, we have to take the help of the empirical models. So now the question is that what is this empirical models? As being technocrats, we have heard, suppose that I'm giving a small example. We are studying basic electrical engineering. So the fundamentals of basic energy, basic electrical engineering is we have to go through KCL, KVL, and based upon that KCL and KVL, we are going to solve our complex circuit. So same things happen here with the help of empirical model. So to avoid the chaos of measurement, we have to take the help of certain empirical models. Means it is given by some renowned researcher who did a lot of research on that particular topic, and developed certain models through which we can estimate the solar radiation data for that particular location. So again here you can ask me one question कि मैडम डेटा तो आसानी से मिल जाता है सभी जगह का, why you are preaching all these things? Hello, hello, hello.
Yes, you're audible.
Yes,
Yeah,
ma'am,
yeah.
you are good.
Am I audible? आप लोग बीच में कुछ बोलिए, otherwise it is getting very monotonous for me.
No, ma'am, you are audible.
Yes, that's why I'm asking the question. You people can ask me, ki, madam, very easily we can have the solar radiation data. It is available on certain website. We can take the data from NASA. We can take the data from MNRE. These are some of the reliable and authentic sites from where we can gather the solar radiation data. Then why you are preaching so much about it? If this is your question, then definitely my answer is yes, you are right. That the data for well-known cities, metro city and well-developed cities are available. But yes, for unprivileged places, it is not available. Suppose that solar radiation data for Kolkata will be available. बस कोलकाता के अंदर बहुत सारा unprivileged छोटा छोटा village होगा, वहाँ का accurate data आपको नहीं मिलेगा. In that case, what you will do? Yes, you have to go to estimate the data with the help of this empirical models. So how to estimate this data? So we have to go through some solar radiation basics, right? And the basics of solar radiation is that with the help of solar radiation geometry, you have to know about the different solar radiation angles, and based upon that you have to get the value of this estimation of solar radiation. So in this slide you will be able to see that one graph is there, variation of direct and diffuse radiation. So you can see that in this graph throughout the year the variation of direct and diffuse radiation has been shown. So again the question is, what is direct radiation, what is diffuse radiation? It is a very common and very basic question. So there are three types of radiation, you know. So first one is direct, or it is also known as beam radiation. The second one is diffuse radiation, and the third one is global radiation. So what is this direct radiation? Direct radiation is nothing but the amount of incoming solar radiation which we are getting directly on the Earth's surface without any scattering part. That is known as direct or beam radiation. And about the diffuse radiation, means diffuse radiation, suppose that I am giving one example. Sunlight is coming and in between some tree came. Means the entire amount of solar radiation we are not able to get on the Earth's surface. वो कुछ टकरा गया पेड़ से, उसका scatter होने के बाद the amount of radiation which we are getting on the Earth's surface, that is known as diffuse radiation. And the sum of this direct radiation and diffuse radiation is known as global radiation, right? So in this slide you can see that here one term is there. Yeah, same thing has been written in this slide, what I have described and shared with all of you. Components direct, straight from the sun, diffused, scattered by the atmosphere, and reflected from the surfaces. And a very important point is there, that is solar constant. Solar constant, the value of solar constant, it is also, the abbreviation is ISC, that is solar constant. The value of solar constant is 1366 watts per square meter. And rest of the thing we have described. So coming to this slide, so this slide has been imposed over here in context of solar radiation geometry and angles. So with the help of this figure number 7, you can have a look about different angles which we have to go through when we are estimating the solar radiation for any location where the exact data is not available, right? So the first and utmost angle is latitude of the location. Every location has its latitude, right? So the variation of this latitude is plus minus 90 degree. Beta is the angle of slope. It varies from 0 to 80 degree. Gamma is the surface azimuth angle. It varies plus minus 180 degree. Del is the declination angle. The value of declination angle we can obtain with the help of this formula, that is 23.45 sine 360 divided by 365 284 plus n, where n is the number of day starting from 1st of January. And this omega is the hour angle that varies from plus minus 180 degree, right? So this figure shows the factors influencing solar radiation. So what are the factors which are going to influence your solar radiation? So it may be sunshine duration, longitude, relative humidity, latitude, extraterrestrial radiation, air pressure, then dew point, ambient temperature, rainfall, sky coverage, cloud cover, day length, sunshine duration, and solar azimuth angle. So these are the sum of the factors which is going to influence your estimation of solar radiation, right? So coming to this figure is telling about sunshine based empirical models. As already I have shared with all of you, if you are not able to measure the data properly, then we have to take the help of the empirical models. So there are so many models, but the starting point, as I have quoted, suppose that we have to go through the basic electrical engineering paper. So we are starting from KCL and KVL. So same happens in case of this estimation of solar radiation. So the basic one was given by Angstrom and Paris-Scott, right? You can see in this one, there are so many models which is related to and known as sunshine based empirical models, right? You can see Italville model, Ogleman model, Ekinglu model, Glover model, Gopinathan model, linear regression model. So all these models, 6-7 models which you are able to see on the slides, all of them are related to sunshine based model. In the previous slide we have mentioned about the factors which are going to affect the amount of solar radiation, and you might have visualized in that slide the sunshine hour was one of them. So here we are talking about the sunshine based model. So you can see that one thing has been missed in this slide. We have shown about so many models, but we have not included the name of Angstrom Paris-Scott model, which is known as the father of sunshine based model, right? So with the help of that model, we are going to estimate the amount of solar radiation for the unprivileged location. So what this Angstrom Paris-Scott model tells about, the equation is given by H0 by Hg by H0 equals to A plus B S by S max, right? So you can see that in this empirical relationship, we have to know the value of Hg. Hg is representing here the monthly average of the daily global solar radiation on a horizontal surface at a location. The unit is kilojoule per meter square per day. So estimating the value of Hg, we have to know the values of the parameters which you can see in the slide 24, they are H0, A, B, S and S max. So definitely I have to let you know what are these parameters are telling about. So already I have discussed about Hg. Hg is nothing but the monthly average of the daily global solar radiation. So H0, what is this H0? H0 is the amount of extraterrestrial monthly average of extraterrestrial radiation on the horizontal surface. What is this extraterrestrial radiation? Extraterrestrial radiation is the amount of sunshine hour which we are getting outside the atmosphere, right? And A and B, though it seems as a very tiny element, but it has a lot impact in this equation. Without knowing the exact value of this A and B, it is impossible. It is impossible to estimate the value of global solar radiation for any particular location under consideration. So for some of the well-known cities, the value of A and B has been given in the index of the books, right? And even in this equation given by Angstrom and Pariscott, it has been suggested that suppose that for which location, for which unprivileged location, you are going to calculate or estimate the global solar radiation, and for that location A and B is not available, then what you have to do, you have to take the help of the nearby city having the same climatic condition, right? So this S, what is this S? S is nothing but the sunshine hour which we are getting on that particular day. Suppose that, for example, if I am talking about today's sunshine hour, how much amount of sunshine hour today I have got? 6 घंटे, 7 घंटे, 8 घंटे कितना मिला, that you have to find out, and based upon that we have to calculate the maximum amount of sunshine hour, that is denoted by S max, and with the help of the formula 2 by 15 into omega s we can calculate it. So many slides are there. So this slide is telling you about the importance of accurate estimation. क्या क्या आपको मिलेगा when you will go through the accurate estimation. So the same things which we have discussed in the previous slides, it will have the optimal system sizing, performance prediction, resource assessment, grid indication, financial viability, environmental impact, right? Again, same question, it is asking how to get the solar radiation data visualization. So through all this, through all these means, you can have the solar radiation data for the location under consideration. They are graphs, maps, time series, histograms, and part diagrams, 3D visualization, interactive tools like that. So these are all about solar energy research assessment. Yes. Then just I will take 5 to 10 minutes. I have to summarize. Yes, a case study. I have taken a case study. It is to predict and validate the performance evaluation parameter for solar radiation forecasting using empirical models and machine learning models. Before coming to machine learning, I will let you know कि first of all, before switching to machine learning models, you have to estimate the data with the help of the model which I have described right now. And when you are able to estimate that particular when you are able to estimate regarding the particular location under consideration, and you are getting the exact means nearby values in with respect to the measured data, then definitely you can switch on the machine learning models according to today's era. So this is the last thing which I will share with all of you. This is a common problem, and how this common problem can be sought out, and how we can correlate it with the machine learning, right? थोड़ा सा आप लोग ध्यान दीजिएगा. Am I audible to all of you? Hello?
Yes,
Yes,
ma'am. You're audible.
Yes,
Yes,
yes. I don't know how much I am able to give you people, but yes, I am trying my level best, because I know it's very difficult to go through each and everything in one session, right? And
yes.
especially when it is a online session. So you can see that in this example, I have written calculate the monthly mean of every day. This part I will discuss fully, and I will left this as the assignment for you people whosoever in this meeting. Humbly, I will request correlate it with the machine learning, right? And in between, if you are not able to correlate, write me a mail. I will help you out, right? So देखिए इसमें क्या क्वेश्चन है. क्वेश्चन पूछा गया है कि कैलकुलेट द मंथली मीन ऑफ द एवरीडे ग्लोबल रेडिएशन on a flat surface at Kolkata. आपके यहाँ का ही है, right? During the month of Feb, if the mean sunshine hour per day is 8.5 hour. अब देखिए पहला चीज मैंने क्या कहा था. The first thing which I have discussed with all of you, one figure has been shown regarding the different parameters which is going to affect the estimation of solar radiation. The first one utmost was the latitude of that location. आपके यहाँ का कितना latitude है. देखिए आप यहाँ latitude है 22 डिग्री 34 मिनट नॉर्थ, राइट? तो एग्जैक्ट latitude क्या हो जाएगा आपका 22 प्लस 34 डिवाइड बाई 60, राइट? देखिए हम लोग 5 किए हैं फॉर कोलकाता. 5 इक्वल्स टू 22 into 34 by 60. It is 22.57 degree. And the value of A and B is available for Kolkata, and that is 0.28 and 0.48. So based upon the recommendation, we have to find out the value of H naught, that is extraterrestrial radiation. आपका मंथ कौन से मंथ के लिए निकालना है? फैब के लिए निकालना है. तो एक फॉर्मूला था ना 284 प्लस एन. एन के बारे में मैंने बताया था नंबर ऑफ डे स्टार्टिंग फ्रॉम जनवरी 1st. तो हेयर यू हैव टू कीप इन योर माइंड कि द मंथ अंडर कंसिडरेशन, in that case we have to take the average value and previous month will have the full value. तो इस केस में क्या होगा, जनवरी का हम लोग पूरा वैल्यू लेंगे और फैब का एवरेज वैल्यू लेंगे. Suppose that if the month was March, then January
Madam?
full. Yeah.
Excuse me.
Yeah.
Madam, I have a request, madam. When you speak continuously in Hindi, I cannot understand, madam. 1 or 2 words is fine, please.
Please pardon, repeat it.
I cannot understand Hindi, madam. When you speak continuously in Hindi, no, I cannot understand what you are saying, madam.
Okay, okay. So sorry for that. Again, I am
Thank you, madam.
repeating it, right? So
Thank you, madam.
starting from the scratch, just I am trying to convey you people ki one question is on the slide. You are able to see it. I am telling ki just you people have to correlate the same numerical with machine learning. So for relating it through the machine learning, what you have to do, first of all, you have to find out or you have to estimate the solar radiation value first. Then whatever data you will get or you will be able to gather, that must be fitted into the machine learning one. So for solving this numerical, what we have to do, as I have discussed in the previous slides, there are certain parameters through which you will be able to find out or you will be able to estimate the value of monthly average solar radiation for that particular location. So in this question, the location is Kolkata and the latitude of Kolkata has been given 22 degree 34 minute north. The month under consideration is Feb and the mean sunshine hour per day is 8.5 hour, right? So based upon that, what we have to do first, we have to find out the value of declination angle. And the formula for obtaining the declination angle is 23.45 sine 360 by 365 284 plus n, right? So how you have written the value of n here over 48 means, as I have communicated to all of you, the month under consideration in the question that must be taken as average and the previous month will be taken as the full one. So January we have taken the full value and for Feb we have taken the average of that one. So here the value of n is 48. So based upon that, the value of declination angle is minus 12.62 degree, right? And again, we have to find out the value of our angle, that you can calculate with the help of the formula cos inverse minus tan phi tan del, and you will be able to get the value of omega s as 84.66, as you can see on in the slides, and you can verify it also. Then the next parameter, the crucial one, which we have to find out, that is x max. And with the help of the correlation 2i15 into omega s, you will be able to find out the day length. And all these input parameters will be fed into the equation h naught, that is the extraterrestrial radiation. You have to find out the value of extraterrestrial radiation, and it very easily you can see it in the slide. So by calculating, you are able to get the amount of extraterrestrial radiation as 29721 kilojoule per meter square per day for the place Kolkata for the month Feb. So by having all this value of all these parameters, you can easily find out the value of monthly average extraterrestrial, monthly average global solar radiation, that is nothing but Hg, and the value is 19062 kilojoule per meter square per day, right? So here, anybody wants to ask any question, please, because you people have to correlate it with machine learning, same data. Please let me know if any question is over here regarding this slide. No. So same thing I have tried to implement it in machine learning, but yes, definitely I will ask some question to all of you. So can you let me know what are the basic parameters which you have to calculate for knowing the monthly average global solar radiation for any particular location under consideration? So definitely the parameter which you have to know is, first of all, latitude of the location, then the value of regression constants, they are A and B. Then based upon that, you have to calculate the number of day starting from January 1st. Then you have to calculate del, that is declination angle, then sunshine hour, then hour angle, day length, and based upon that, you will be able to get the value of monthly average global solar radiation, right? So these values have been incorporated in this machine learning technology. So you can see in this slide the workflow of this programming part, which I went through. So what I did in this one, so you can see in this slide what we have done in this programming part. So first of all, you can see that we went for data processing, and then after that machine learning algorithms, then a model of prediction and evaluation. And the second part is related to data pre-processing. So we begin with meteorological raw data obtained from, because for data processing, we need a lot of data. So we have taken the help of the NREL side, which typically includes parameters like temperature, humidity, wind speed, solar angles, and previous radiation values. So this raw data is often noisy, incomplete, or inconsistent. So therefore, we perform a structured set of operation, right? I'm just going through the things which I have marked as in my pages. So first of all, we went for data cleaning. You are aware from that part. Then feature selection, outlier removal, then data reduction and normalization. Finally, the data is split into training 70% and testing 30% for both inputs, right? And in the next section, we have applied the machine learning algorithms. We went for random forest, multi-layer perceptron, that is MLP, and k nearest neighbors, that is KNN. And then we have tested all this algorithm on the base of sensitivity analysis. Validation of that part we have done with the statistical test error, that is RMSE root mean square error, MAE mean absolute error, and R square score, right? So so a comprehensive analysis is performed across all models, and we have chosen the most successful model for for deployment. So we can say that overall this workflow ensures a robust data-driven and optimized machine learning approach for accurate solar radiation estimation. So these are some of the values related to that. For that, we have chosen the location Jamshedpur, Ranchi. 5 location we have, 2 location we have chosen, and based upon this location, these are the different input parameters which we have considered. Based upon that, these are the values which we got, right? So these are the optimization technique and the machine learning models which we have used. Based upon this, these are the results, right? So due to time limitation, I will not be able to discuss all these things. So these are the final table which we have got for the places under consideration. They are Jamshedpur and Ranchi. So in the conclusion, we can say that for the Jamshedpur location, random forest performs best values with R square value of 0.9247 for DHI and 0.8521 for DNI. Like that, after RF, KNN performs better than MLP. For Ranchi also, random search performs best with R square score of 0.8982 for DHI and 0.8696 for DNI. So we found the value of training and testing outputs to be different for R square. For example, the difference of 0.050498 for both breed search and random search. So I will gently urge all of you, till then you are not applying it by your own, it's very difficult to get all these things, right? So overall conclusion, we can say that India has significant solar energy potential with abundant solar radiation available throughout the country. But again, the question is same, how to utilize it properly. So these are some of the references which I went through. Thank you. So based upon that, if any question is there, you can put it in the chat box. I can revert it back to you. So thanks all.
Participants, if you have any questions regarding the session, you can ask. Feel free to ask Namrata
You
ma'am.
can ask, and even you can put it in the chat box. I will answer it, and I will send you back. So depending upon your convenience, you can ask me if something is there, because I know it's a very big topic. So in one session it's very difficult, but I tried my level best. I don't know how much you people have gathered it, but yes, let me know if any question is there, please. I think there is no question.
Okay, ma'am.
Okay.
I think our participant don't have any questions. Their doubts are clear.
Right. Okay.
Okay, just a minute, ma'am. First of all, we would like to thank you, ma'am.
Thank you. Thank you so much.
Delivering such a session, and
I don't know how much fruitful it was, because if no question is coming from the session, it means either I was not able to make them understand or I was not able to grab their problem. Right?
no, ma'am. The numerical, I am telling, I will try it on my for the numerical you gave. I will personally try it.
Please, because 2 of my research scholars are working in the same area. They are doing it with the help of ML and AI. So it is the topics like data driven based optimization techniques for renewable energy based system. So they are doing the same work. I know it's very tough to understand all these things in one lecture, but yes, I tried my level best. But I am always willing to help all of you out, those people who were in the session. If they need any suggestion regarding that one, I'm available.
Okay, ma'am. And from our side, ma'am, just we want to. Is it visible, ma'am?
Yeah. I'm not able to see anything, right? Yeah, please.
Okay. There's a small note of appreciation to you from our side. We
Yeah.
look forward to learn more from you, ma'am. It
Thank
was
you.
really
Thank you so much.
okay, ma'am. Have a
Thank you.
nice
Thank you. So
day.
Priyanka madam is there?
Priyanka, ma'am. Hello.
I think she is not there. Right? This is the beauty of online lecture.
No. Actually, she is on her way home.
Okay, fine. No issue. She did a lot of pain during connecting me. Whenever
Yes.
she was calling me, I will be in the classroom or busy in some meeting. So she
Yes.
took a lot of pain to connect me.
She is on her way home actually. So
Okay,
maybe
no.
she could
Okay,
attend right now. But she was
okay,
right.
fine.
She was interacting with you also in the session.
Right. So thanks to all of you. Once again, I will place my sincere gratitude and thanks to all of you to listen me patiently for at least 1 hour. Thank you so much. So
Thank
with
you, ma'am.
these words, I'm just leaving this meeting with the permission of all of you. Okay?
Okay, ma'am.
Thank you.
Okay. Participants, we will be meeting in our next session that will be starting 7:30. So till then, stay connected and have patience because our
Okay,
next
sir.
speaker, will join us very soon.